What specific problem does the proposed OpenAI reasoning model, O3, aim to address in competitive programming, and how does it differ from earlier models like O1 IOI?
The proposed OpenAI reasoning model, O3, aims to address the limitations of earlier models, such as O1 IOI, by eliminating reliance on human-engineered test time strategies for competitive programming. Unlike O1 IOI, which utilized complex, handcrafted inference strategies to enhance performance, O3 autonomously develops and executes its own test time reasoning strategies through reinforcement learning. This shift allows O3 to achieve a significant performance leap, as evidenced by its CODEFORCES rating increase from 2214, 98th percentile, with O1 IOI to 2724, 99th percentile with O3. Additionally, O3 demonstrates more insightful and deliberate chains of thought, employing self-imposed validation mechanisms, such as generating brute force solutions to verify outputs, which enhances the reliability of its solutions. Overall, O3's approach represents a more advanced and independent reasoning capability in competitive programming compared to its predecessors.
How does the proposed method or algorithm work? Please illustrate the methodology step by step, from generating candidate solutions to the final submission process.
The proposed methodology for the O1 IOI and O3 systems involves several key steps in generating candidate solutions and final submissions for competitive programming tasks. First, the model generates a large number of candidate solutions for each problem, with O1 IOI sampling 10,000 solutions per subtask, while O3 samples 1,024 solutions from a single prompt. Next, the generated solutions are clustered based on their outputs on model-generated test inputs, ensuring that similar outputs are grouped together. After clustering, a re-ranking process is applied, where each cluster is scored based on solution quality, errors on test inputs, and performance on public test cases. Finally, the top-ranked solutions from the clusters are submitted, with O1 IOI submitting up to 50 solutions per problem, while O3 selects the top 50 solutions based on a simpler scoring method. This streamlined approach allows O3 to achieve high performance without relying on complex, human-engineered strategies, demonstrating its ability to autonomously develop effective test time reasoning.
Can you provide a simple illustrative example of how the clustering and re-ranking techniques enhance the solution selection process in the O1 IOI system?
In the O1 IOI system, the clustering and re-ranking techniques significantly enhance the solution selection process by organizing generated solutions based on their outputs for model-generated test inputs. For each subtask, the model first generates 256 random test inputs and then clusters the solutions that produce matching outputs on these inputs. After clustering, the system scores each cluster based on a learned scoring function, the quality of solutions, and penalties for submission attempts. This method allows O1 IOI to prioritize the most promising solutions, ensuring that only the top-ranked solutions from the best-performing clusters are submitted. This structured approach not only improves the likelihood of solving subtasks effectively, but also maximizes the score by focusing on high-quality solutions, as evidenced by the model's improved performance in competitive programming contests.
What theoretical or practical benefits does the O3 model offer over O1 IOI regarding competitive programming performance?
The O3 model offers significant theoretical and practical benefits over O1 IOI in competitive programming performance. Theoretically, O3 demonstrates a substantial leap in problem-solving capabilities, achieving a CODEFORCES rating of 2724, 99th percentile, compared to O1 IOI's 2214, 98th percentile, indicating its ability to tackle a wider range of complex algorithmic problems with higher reliability. Practically, O3 operates without relying on human-engineered test time strategies, instead autonomously developing and executing its own reasoning strategies, such as generating brute force solutions for verification, which enhances its solution reliability. This self-imposed validation mechanism allows O3 to refine its outputs based on real-time feedback, leading to improved performance in competitive settings. Overall, these advancements confirm that O3's large-scale reinforcement learning training enables it to surpass O1 IOI by independently learning to generate, evaluate, and refine solutions effectively.
How was the performance of the proposed models validated in the context of the CODE-FORCES and IOI benchmarks? What metrics were used to assess their effectiveness?
The performance of the proposed models, specifically O1, O1 IOI, and O3, was validated through simulations of CODE-FORCES contests and participation in the 2024 International Olympiad in Informatics, IOI. For CODE-FORCES, the models were evaluated under conditions that closely mirrored real competitions, using the full test suite for each problem and enforcing time and memory constraints. The effectiveness of the models was assessed using ratings based on their performance, with O1 achieving a rating of 1673, 89th percentile, O1 IOI reaching 2214, 98th percentile, and O3 surpassing this with a rating of 2724, 99th percentile. In the IOI context, the scoring system was subtask-based, with O1 IOI scoring 213 points with 50 submissions and improving to 362. 14 points with 10,000 submissions, while O3 achieved 395, 64 points under the same submission limit. These metrics, including percentile rankings and total scores, effectively demonstrated the model's competitive programming capabilities and improvements in reasoning performance.
What limitations or drawbacks do you identify in the proposed approach, particularly regarding its reliance on reinforcement learning and the absence of human-engineered strategies in the O3 model?
The proposed approach, particularly in the O3 model, has notable limitations stemming from its reliance on reinforcement learning, RL, without human-engineered strategies. While O3 demonstrates significant improvements in competitive programming performance, it may lack the nuanced understanding and targeted strategies that human intervention can provide, as seen in the O1 IOI model, which utilize specialized test-time inference strategies. The absence of these handcrafted strategies could lead to less optimal performance in specific scenarios where tailored approaches are beneficial. Additionally, the simplified selection method in O3, which involves choosing the top 50 solutions from a larger pool without subtask-specific prompts, may not capture the complexity of certain problems as effectively as the more intricate methods employed by O1 IOI. This reliance on autonomous reasoning could also result in inconsistencies or errors in problem solving, particularly in cases where the model's self-generated strategies may not align with the best practices established through human expertise.